If I tear a piece of paper, is it still paper? Yes. But if I burn a piece of paper, is it still paper? No. That is the difference between physical and chemical change. Hi, my name is Rachel, and welcome back to my chemistry lessons. Today, we are going to be learning about the two types of changes in matter, which are the physical change and the chemical change. First up, we are going to talk about physical change. This is a change in which a substance undergoes a change in its form, its shape, and its state without forming a new substance, and it is reversible. So let's use an example to understand what we're talking about in this definition. I'm going to be using the melting of ice to explain this definition further. So when we say ice melts, it's a physical change. And what characterizes that? The form changes. Ice is already solid. Ice is hard. The form of ice when it melts is definitely different from the form that it has when it is solid. Secondly, the shape changes. So let's say it's an ice cube. That means the shape is a cube, right? And when it melts, it turns into a liquid, and then we all know that liquids have no definite shape. So it takes the shape of whatever container it is in, and that is what we mean by the shape changes. Also, thirdly, the state changes. So I spoke about this in my previous video, states of matter, and the main states of matter are solid, liquid, and gas. So when we say the state changes, it just means that the solid turns into liquid during the melting of ice, and it does not form any new substance. So this ice we're talking about is water, right? And when ice melts, it's water. When ice freezes, it's still water, and it is reversible. So what we mean by this is that if I have my ice and I say, oh, I want water instead, all I have to do is leave this ice to melt, to leave it to thaw, and it will become water again. If I say, oh, I don't want to drink water again, I want my ice back, all I have to do is keep it to freeze, and once it's frozen, it turns back into ice again. So that is why it's easily reversible. So you don't have to do so much for it to reverse back into the initial state that it was. Now, there are certain signs or characteristics that we can use to determine if a change is physical or not. And in this case, we're talking about physical changes. So in a physical change, you expect the substance to experience a change in its shape, just like the ice. The shape of the ice changed. So before a physical change is acted upon a substance, the size could either be bigger or smaller, but when that change occurs, the size could either reduce or increase, but still change for sure. And there is a change in its state. So, like we said, solid, liquid, gas, or any other state of matter, and this is usually reversible. So, like we spoke about for the ice, all you have to do when you want your ice back, when you have water, is just to freeze it. And when you have your ice, you want water, all you have to do is melt it. So that is what we mean by it's easily reversible. You don't have to do too much for it to go back to the state that it was in. Some other examples of physical change is dissolving sugar in water, dissolving salt in water, breaking glass, cutting of paper, and so on. So I want you to mention one example of a physical change in the comments that I haven't already said. Now we are going to move to chemical change. A chemical change is a change in which one or more substances are transformed into new substances with new properties, and they are not easily reversible. So we are going to break this down using the example of cooking. And the food that is being cooked is fried rice. Now, fried rice consists of rice, vegetables, and other ingredients mixed together. So these are the substances. And one or more substances, that's the rice and the vegetables, are transformed into new substances with different properties, and it's not easily reversible. So what we mean by they're transformed into new substances is that the rice that I started cooking with was raw, and at the ending, it is cooked and soft rice. Raw rice is hard, while the cooked rice is soft. So that is what we mean by they have different properties. The property of the rice before was hard, and now it's soft. The vegetables as well, they were fresh, but now they are cooked, and this is not easily reversible. You can't reverse the process to get back your raw ingredients. It doesn't work that way. So there are signs and characteristics that we can use to determine if a change is actually a chemical change, and this is the color change. Still going on with our cooking example, Raw rice does not have that vibrant fried rice color, but after it has undergone the chemical change, the color changes, as well as gas produced. When we cook, generally gases are produced. It has a new smell. So in this case, it is food that is being cooked, and after you finish cooking your food, the aroma is really nice. So that's what we mean by it has a new smell. Heat and light is released. During cooking, heat is definitely released. That's why the food comes out hot. And in other chemical changes, light is produced as well. And lastly, it is not easily reversible. You can't give me a plate of fried rice and I would say, no, I just want the fresh carrots. I just want the fresh vegetables. I don't want this. Give me back the fresh vegetables. It won't work. It's not easily reversible. So that's what we mean by it's not easily reversible. You can't change it back to what it was easily. Some other examples of chemical changes include rusting of iron, fermentation and decay of substances, and changes in an electrochemical cell. There are so many more examples of this, so I want you to tell me one example of the chemical change in the comments. Now we are going to be looking at the differences between a physical change and chemical change. First up, in a physical change, no new substance is formed. Like I spoke about earlier, in a case where ice is melting, if ice melts, the substance is still water. When the liquid freezes, it is still water in ice form. So there is no new substance formed. Whereas in a chemical change, new substances are formed. Like I mentioned when I was talking about fried rice as an example, when all the ingredients come together and undergo a chemical change, new substances are formed. Secondly, a physical change is usually reversible. So I can easily freeze the water to get ice. I can easily melt the ice to get water. So that is why it is reversible. You can easily change it from the previous state to the new state and the new state to the previous state. It is that seamless. But it's not the same for chemical change because it is not easily reversible. Like I said earlier, if I burn paper, for example, what I get is ash and I get carbon dioxide and so many other, substances. So I can't say that I want my paper back after I have burnt it because I can't take the ash, take the carbon dioxide, take the other substances and say, okay, boom, here's my paper. It doesn't work that way. It's not easily reversible. Thirdly, only the form changes. And for the chemical change, the composition changes as well. So the properties change, what the material or the substance is composed of changes because it has undergone a chemical change. And it doesn't involve great heat change. So when ice melts, for example, the heat that is involved in the whole process is not something that is not so significant, unlike when there is a chemical change. So it involves a considerable amount of heat change. So when you are cooking, for example, there's a great amount of heat that is involved in it. When you're burning paper, there's a great amount of heat that is involved in that whole process. So that is why it involves a considerable amount of heat change as opposed to a physical change which doesn't involve great heat change. And a quick hack to easily know if a change is physical or chemical is that for a physical change, no new substance is formed, but for a chemical change, a new substance is formed. So if you have a question with different options, what you should look out for in the options is, in this scenario, is there a new substance formed or not? That would determine if it is a physical change or a chemical change. All right, that is it for physical and chemical changes. I hope this video was very explanatory. I hope you learned something new. Don't forget to answer the questions that I asked earlier. List one example each of physical change and a chemical change that I've not already mentioned in the comments. Please don't forget to like this video, subscribe, and share this video with anyone you think it will help. Thank you so much for watching. Don't forget to go back to my previous video, States of Matter, if you haven't already watched it, so you can have a better understanding of this topic. It will be linked in the description. Thank you for watching. I will see you in my next lesson. Bye.